Okay, so yesterday we talked about two formulas. Started with two formulas. One was the sum of the interior angles. One was finding each interior angle. And then we learned about the sum of the exterior and then how to find each exterior. So let's kind of review those first, right? So sum of interiors is what?
N minus 2 times 180.
Good. N minus 2 times 180. So if I wanted to find each interior, I would do what with that? Good. Divided by n. Good. Each interior. And it has to be of a regular polygon. And then we said sum of the exterior, which is what? 360. No matter how many sides. So if I wanted to find an individual exterior, I would do what?
360 divided by n.
Good. 360 divided by n. So that's kind of the formulas that we covered yesterday. And then it's the tweaking of it depending on what it's asking for. So for 1, it says find the sum of the measures of the interior angles of a convex 24gon. So my n is 24. And then I'd get 24 minus 2 times 180, which is 22 times 180. God bless you. 18, 22. See if I could do better with math than I did yesterday. I'm sure it's bad. 6, 9, 3. So 3,960 degrees. God bless you. Raise your hand if you got it right. Okay, good. All right, sum of the measures of the interior angles of a convex polygon is 5,040. Classify the polygon by the number of sides. So again, it's sum of the measures, which means n minus 2 times 180. This time it's actually giving us the sum, which would be 5,040. So what we don't know is the n. So if I wanted to work backwards to solve this for n, what's one thing I could do? Because there's 2 steps you could take from here. I could distribute that 180, so I'd get 180n minus 360 equals 5,040, and then I would add the 360. 180n equals 5,400. And then divide both sides by 180. So the zeros cancel. I can reduce this. I could go 9. 9 goes into 54. That would be 60 times. 9 goes into 18 twice, and then I'd get 30. So this would be a 30 gon. So if a question like this came up, could you ever get a decimal if it asked you to classify it? No. So if it asked for each interior, right, I could get a decimal. If it asks for each exterior, I can get a decimal. But if I'm classifying it, I'm trying to find n, you should never get a decimal, right? Because otherwise you can't have something with a 0.2 of side length. All right. So the other way, if I had started from here, did anybody divide by 180 from the beginning? Okay, so that's the other way to do it. I could have divided by 180 and then just added the 2 to the other side. Either way works. Both get you the same answer. Questions on that one? All right, now it says find the value of x. So what are all those on? Like what location are all of those measurements or variables? They're all exterior. What do I know about the sum of the exterior? 360. So this is definitely not a regular polygon, which means I can't like figure out how many sides it is and divide 360 by it. What I can do is say that 72 plus 46 plus 110 plus x plus 3x equals 360. So this is 118 plus 110 plus 4x, 228 plus 4x equals 360. Subtract the 228. And then divide by 4. Raise your hand if you got that one right. Okay, good. So that's the only way that you would see like a non-regular polygon and you're finding an individual angle, is you would either, if it's inside, find out what n minus 2 times 180 is, and then add all of them up and set it equal to that. And if it's exterior like this one, add them all up and set them equal to 360, because that's what the sum of the exterior would be. Okay, number 4 says find the measures of an interior angle and an exterior angle of a regular 36 gone. So measures of an interior angle means just one. So each interior would be n minus 2 times 180 divided by n. And my n is 36, so 36 minus 2 times 180 over 36. 34 times 180 over 36. And then I can either multiply that top out and then divide by 36 or reduce it as much as I can as I go. So I can say that this would be 17 and this is 18. And I can go a step further and say that this is 1 and this is 10. So all that's left in the top is 17 times 10, or 170, and the bottom is just 1. So again, I could have multiplied straight across. I could have done 34 times 180, got that, and divided by 36. But in my opinion, the smaller the number, the easier to work with. So reduce as you go, if you can. All right, then it said each exterior angle. So what did we say? If I wanted to find the exterior angle, I would do what? Good. 360 divided by n, which in this case is 36. Good. Questions overall on any of those? Okay, so a couple of formulas that you want to make sure that you pay attention to, because as we continue, things are going to get a little, we're going to shift a little bit and start talking about quadrilaterals. Okay, so 8.2 is called Properties of Parallelograms. So the next couple of sections, really the rest from here on out to the end of the chapter, is all dealing with quadrilaterals that will be parallelograms, and then we're going to keep going and narrowing down our types of quadrilaterals to eventually squares and rhombuses and rectangles, kites, trapezoids, and you're going to learn a bunch of properties. So this is one of those where this chapter, where it's probably a good idea to keep a running note of all the properties. So like in section 8.2, we're going to learn about parallelograms, and then we're going to narrow it down and learn more things about squares, rhombuses. So if you're one of those people that's really, especially making an outline or notes, it's probably a good idea to start compiling one note from this chapter, okay, because it's a lot of properties. All right, so a parallelogram, by definition, is a quadrilateral with two pairs of parallel sides. So the opposite pairs of sides are parallel. And then to write the name of a parallelogram, you can use that little symbol. So you guys love anything that requires you to write less. You don't have to write the word parallelogram, because you'll spell it wrong half the time anyway. So that parallelogram that's there has that little slanted symbol, and then I would call that A, B, C, D. And really you could call it anything you want as long as it goes in order, either clockwise or counterclockwise. So I can also call this parallelogram BCDA, or parallelogram CDAB. Okay, as long as I either go clockwise or counterclockwise. I just can't say like BDCA. I can't come across of it. So by definition, a parallelogram, God bless you, has opposite sides parallel. So as soon as I say this is a parallelogram, you should be able to tell me that AB is parallel to CD and BC is parallel to DA. Okay, so these are theorems, but really just think of them as properties of parallelograms. Don't get all up in your head about a theorem, okay? The first one is that a quadrilateral is a parallelogram. A quadrilateral is a parallelogram, then the opposite sides are congruent. So first thing is opposite sides are parallel. Now we're adding to it opposite sides are congruent. So if I told you that this was a parallelogram, you should be able to tell me that AB is congruent to CD and BC is congruent to AD. Theorem for 8.4 and 8.5 are two additional properties. 8.4 says if a quadrilateral is a parallelogram, then the opposite angles are congruent. So we've got opposite sides congruent, now we've got opposite angles congruent. So if this is a parallelogram, then angle B is congruent to angle D, and angle A is congruent to angle C. And then 8.5, if a quadrilateral is a parallelogram, then its consecutive angles are supplementary, meaning one after the other. All right, so angle A plus angle B is 180, angle B plus angle C is 180, C plus D, and D plus A. So consecutive as I go around it one after the other, whether it's clockwise or counterclockwise. So why do you think this happens? Look at the parallelogram as though these are two parallel lines and this is a transversal. What's the special relationship between angle B and angle A? They're same side interior, right? And what's true about same side interior angles if the lines are parallel? They're supplementary. So as I move around that parallelogram, it's going to continue to happen. If these two are my parallel lines and this is my transversal, then B and C are same side interior, so they are supplementary. Okay? So that's where this comes from. All right, last one, Theorem 8.6. If a quadrilateral is a parallelogram, then its diagonals bisect each other. So if I drew the diagonals, remember, go from non-consecutive vertices. In this case, my diagonals would be BD and AC. They bisect each other. What does bisect mean? Cuts it in half. So AZ would equal ZC. This would equal this. And BZ would equal ZD. All right, so it says, name all the pairs of parallel lines. In pairs. Give me one pair of parallel lines. If this is a parallelogram, obviously this has to be a parallelogram. So A, B, C, D is a parallelogram, which you'll either see like that, like obviously that's saying triangle A, B, C, D, or it will say A, B, C, D is a parallelogram. Okay, so give me one pair. Emily, had your hand up. Good. BC is parallel to AD. And Leah, you had your hand up? BA is parallel to CD. Good. So BC and AD are parallel, and BA and CD, or AB and DC. You can put those letters in any order. Okay, number 2 says name all the pairs of congruent angles. So there, I'll give you a hint that there's a lot of them. Give me a pair.
C and A.
Okay, so because we have this line in here now, we've got to use 3 letters. So you're saying these two, right?
Yeah.
So I'm going to say angle BAD and BCD, because C is technically this whole angle or this angle or this angle. So you've got to use 3 letters. Okay, give me another pair. Both pairs of opposite angles are congruent, right? So we've got one pair. What's the other? Leah. Good. So these are congruent to these. Anything else you see there that's congruent? What about if I took out everything we just learned about a parallelogram? Do you see anything else in there? Go ahead. Your vertical angles, BEC and angle AED. And then following that pattern, got CED, BEA. Okay, and then 3 says name all the pair of congruent segments. So the first thing we learned about the sides of a parallelogram are what? The opposite sides are congruent, right? So BC is congruent to AD, and BA is congruent to CD. And then we learned another property about congruent stuff, congruent segments, which is what? What happens to my diagonals? They're bisected, right? So BE equals ED, and CE equals EA.
Oh, they're not together?
No, along each one. So this one is congruent to this one, and this one is congruent to this one. Not necessarily all 4. Does that make sense?
But aren't they congruent to each other?
No. The diagonals themselves are not. They are just bisected. So you'll learn that that's true about a rectangle, but not all parallelograms. So all that information you know now about a parallelogram. All right, this one says RSTU is a parallelogram and find the missing sides or angles. All right, so let's do the quick ones, right? So A, okay, X is opposite the 80, right? And those would be congruent. X is 80 degrees. And then what do I know about the relationship between either angle U or angle S and angle T? They equal 180, which means that angle T would be 100, and so would angle Y. And then opposite sides are congruent. So if this side is 9, then B is also 9. Okay? No actual arithmetic needed there, except for the subtracting from 180. All right, so B.
Are there going to be proofs?
Not on this section, but eventually, yeah. All right, so on B.
Okay. I like this.
So the easy one would be the 12 and the A, right? This is opposite sides are congruent. Okay? These diagonals bisect each other, so this would be 9. And then I've got these interior angles, but if these are parallel lines and I have a transversal,
45.
45 equals Y because those are alternate interior. Everybody sees that so far?
Yeah.
Yeah? Okay. I can go that these two would add up to 80, which means these two have to add up to 80. Okay. I can make a triangle in here. So I could say that if this is 40, where'd it go? This is 35, okay? These also have to be, not 80, sorry, not 80, 100, okay? Those also have to be consecutive. So angle X, which is actually not, it's not there, it's that whole angle. Angle X would be 100 degrees.
The other one would be 80 though, right?
So RUT is 80, RST is 80. Is that what you mean? The other one? Yeah, okay. And then C is just your opposite sides. Okay, this time you've got two variables. Opposite sides are congruent, which means 4x equals 8 and x equals 2. And 3y plus 4 equals 13. 3y equals 9 and y equals 3.